Hi y'all! I sincerely encourage you to watch my first video of the series before coming to this one. Having said that, let us start off at where we left in our last video. Now, LT resources are allocated both in time and frequency domain. So we need to study each domain and look at how the allocation is done. Let us start with the time domain, which I feel is a bit straightforward compared to the other one. So in time, 1 LT frame is equal to 10 millisecond. LT is long-term evolution and the standard radio technology for 4G. Now, 1 LT frame is divided again into 10 subframes, which means that those subframes are 1 millisecond long in the time domain. Further, one subframe is divided into two time slots of 0.5 millisecond each. These slots, or rather each slot, can have either 7 or 6 OFDM symbols, 7 in the case of short cyclic prefix and 6 in the case of long cyclic prefix. Now, to prevent intersymbol interference between subcarriers or to make sure there is no overlapping of OFDM symbols, a guard interval is added at the beginning of the OFDM symbol, which can differ based on the time of arrival of an OFDM symbol, but for this exercise we'll consider approximately 4.76 microsecond. So time allocated for each OFDM symbol is equal to 66.67 microsecond. Now that number 66.67 microsecond is important and let's keep a note of it. We'll move to the frequency domain now. To allocate resources in this domain, the key parameter defined is physical resource blocks or PRB. One PRB is equal to 12 subcarriers. Considering one subcarrier or subcarrier spacing has a frequency of 15 kHz, one PRB is equal to 180 kHz of frequency. So that is the smallest resource allocated in LTE in terms of frequency. The channel bandwidths that are defined in LTE in the 3GPP specs are 1.25, 2.5, 5, 10, 15 and 20 MHz. So to allocate resources for these channel bandwidths, we need to calculate how many physical resource blocks are needed to fill given channel bandwidth. Considering the resource blocks in the transmission bandwidth fill up around 90% of the channel bandwidth, the amount of resources we need to allocate is always less than the numbers that you see on screen. Now, as examples, a 1.25 MHz channel bandwidth can be allocated using 6 physical resource blocks. 2.5 MHz channel bandwidth can be allocated using 12 physical resource blocks, and so on. Before we move to CPRI or Fronthaul bandwidth, let us take a quick look at the mid-haul, backhaul IP bandwidth possible with the kind of resources we have discussed so far. Let us pick 2 MHz as the channel bandwidth. So how many physical resource blocks do we need to support this 2.5 MHz? The answer is 12. Now how many subcarriers do we have for those resource blocks? Well, it is 144 subcarriers. Now let us assume 64 COM is the modulation scheme used in this case. So how many bits are allocated per symbol with this modulation scheme? Well, it is 6 bits per symbol. Now if you assume short CP has been deployed, in that case NCP is equal to 7 symbols. For a 0.5 millisecond time slot, the bits carried is 144 subcarriers multiplied by 7 OFDM symbols multiplied by 6 bits per OFDM symbol, which is 6048 bits. Now for a 1 millisecond subframe, it will be 6048 multiplied by 2, which is equal to 12,096 bits. Thereby, the resulting data rate of an LT subframe is 12,096 bits per second or 12 Mbps. And this is for that 2.5 MHz channel bandwidth. Note, this is the data rate for each transmitting antenna per sector. If we have 2x2 MIMO configuration for that antenna in that sector, the resulting data rate is 24 Mbps. And if the same configuration is replicated across 3 sectors at a cell site, the resulting data rate is 24 multiplied by 3, 72 Mbps. The effective data rate is less than this value as some resource elements of that resource block is used for control and signaling. I hope I made some sense as I have thrown a lot of numbers at you in this video. If you think things will get any simpler beyond this, well, you are wrong. The Fronthaul calculation is a bit more complex and we'll cover that in subsequent videos. Thank you so much for watching this.